This is the third video for the 3.4 notes, and it is the last section of these notes. So the 3.4 notes have been focusing on calculating your x and y intercept using standard form. So at this point in the notes, we introduced a new vocabulary word. So if you haven't noticed in Chapter 3, there are a lot of vocabulary that mean the same thing. It's different words that mean the same thing, and this is no exception. So here we introduce the vocabulary zero of a function. So the zero of a function is the x-intercept of the function. So remember, the x-intercept is where that graph is touching the x-axis. So when they ask you to find the zero of the function, they're asking you what's the input that would make the output of the function equal to 0. Okay? So in class, the first thing that I showed you guys with this example is that you could find the zero of a function, and here's the function that we used, f of x equals 2x plus 8, by using your calculator. So I figure this is probably how most of you are going to do this in an assessment situation, or if you're in class and you have access to a calculator. So here are the steps. The first thing you're going to do is enter that equation in y equals. Don't forget, guys, we've been talking about function notation, and f of x equals is the same thing as saying y equals. So all I've done here is entered 2x plus 8 into my calculator, and then I pressed graph so that I could actually view the graph. And then I just took a picture of my calculator and inserted it here for you guys to look at so that we can talk about it. So notice this graph is touching the x-axis right there. So we can actually count the little marks and see that this is crossing at what appears to be 4 on the x-axis. But we could also calculate that by just simply plugging in a 0 for y and solving for x. If we want the zero of a function, what we're looking for is what input, which means what x value, would make the output, which remember that means your y value, equal to 0. So I can calculate that by putting a 0 in and solving. So here, the opposite of adding 8 would be to subtract 8. So I'm going to do that, and I get negative 8 equals 2x. The opposite of multiplying by 2 is dividing by 2, and I find out that yes, I was correct. The x-intercept of this function occurs at negative 4. And you can see that right there on the calculator as well. Now, one of the most common mistakes with this, when you see zero of a function, you've got to make sure you're looking at the x-intercept, where it crosses the horizontal axis, the x-axis. You do not want to look at the y-intercept, so please be careful with that. Okay, so we have 4 examples here that we worked in class where you had to find the zero of the function. So what I'd like for you to do now is you can pause, and if you have a graphing calculator, then you can calculate the x-intercepts that way by entering the equation and just looking on your calculator. Or if you don't have a calculator, you want to put in a 0 for y and solve for x. Then you can restart the video and check your work with mine. Okay, so hopefully you didn't have any issues with that. I decided to go ahead and show my work, and so instead of using a calculator, I substituted in 0 for y, and then I solved for x. Because remember, the zero of the function is the x-intercept. So to find the x-intercept, all I'm doing is looking for where is y 0. So I solved those equations and I found out that the answer for number 5, the zero of the function, occurred where x is equal to 4. For number 6, I found out that the zero of the function occurred where x was equal to negative 4. And on the last one, number 7, I found out that the zero of the function occurred when x was equal to 10. So from that point, we went on to a verbal model. We went on to a word problem where not only did we have to find the zero of the function, but then we have to explain what it means in context, okay? So here we have an artist who's renting a booth at an art show for $300. They gave us the function f of x equals 50x minus 300 to represent the artist's profit. So remember, profit is the amount you make after expenses, which is why they are subtracting that 300 from their x, which was the number of paintings that the artist sells. Okay, so the 300, they have to pay that, so that comes off the amount they make, and the rest would be the profit. So in order to find the zero of the function, remember the zero of the function is where the output is equal to 0. The output of the function is f of x, or y. Okay, so I'm going to substitute in a 0 for y, and I'm going to solve for x. So I have 0 equals 50x minus 300. The opposite of subtracting 300 would be to add 300 to both sides, so that's what I'm doing first. Those will cancel, and I wind up with 300 equals 50x. Then from there, the opposite of multiplying by 50 would be to divide both sides by 50. And when I do that, I find out that x has to be equal to 6. So I know that this represents the zero of the function, okay, or the x-intercept of the function. Well, the next question that they ask me is, well, what does that mean? So if you go back into your problem, they told you x is the number of paintings the artist sells. Well, if this person only sold 6 paintings, so if I put a 6 right there, 50 times 6 is 300, and 300 minus 300 makes my output, which remember your output is supposed to be the profit. So at 6 paintings, we know that the artist will break even. That means they don't lose money, but they also didn't make any money. So the zero of this function means that when the artist sells 6 paintings, they break even. And remember, that means they haven't made or lost any money. So in reality, what we really hope to understand by this is that the artist really needs to sell more than 6 paintings in order to actually get a profit or make some money. Okay? So this last problem is basically similar to the last one, only it's taking it that extra step, and it's actually asking me to find both the intercepts and interpret them. So what I'd like for you to do is pause the video and see if you can work this problem on your own. Then you can restart and check your work with mine. Okay, so for this problem, the first thing that I did is I calculated my intercepts so I found my x-intercept by subbing in 0 for y, solving for x, and I found out that my x-intercept occurs at 30. Then I did the same thing for the y-intercept, only I subbed in a 0 for x and solved, and I found out that y would be equal to 18. So right here it asks me to interpret what that means. Well, the x-intercept shows that you could seat the 180 guests using 30 small tables and no large tables, or the y-intercept shows that you could seat those same 180 guests using 18 large tables and no small tables. Now this second part is just asking to find 4 possible situations or combinations of small and large tables that would fit this problem. So I could seat 180 people by using 5 small and 15 large, 10 small and 12 large, 15 small and 9 large, or 20 small and 6 large. Now there's a lot of different ways you could do this. What I did is I graphed the equation and then I looked for the whole number ordered pairs that fell on my line, because those represent your x and y coordinates for this scenario that equal 180 guests. Okay? So we did this in class and we're going to do more of that part. So if you're a little shaky on that, that's okay. We're going to practice some more. So if you have any questions, please make sure you watch the 3.4 homework video, or you can come in for tutorials. And I will see you in class tomorrow.